Hi there, and welcome to this lesson on Pure Mathematics 1, Chapter 1, and we're up to 1.5, a section called Surds. Surds, slightly strange name. What is a surd? Well, a surd is a multiple of the square root of a positive integer. So, for example, root 2, root 11, 5 root 3, or 17 root 3. The number inside the square root has to be a positive integer, but it could be any multiple of that. There are two rules for manipulating surds. The first one is if you have the square root of two things multiplied together, the square root of AB, you can split that into two parts, the root of A times by the root of B. So, for example, if you had the square root of 18, the square root of 18, the 18 can be split into two parts, which would be the square root of 9 times 2, which you can then split into 2. The root of 9 times by the root of 2. The root of 9 you can do, that is 3. So you'll have 3 root 2. The other rule is very similar. As well as multiplying, if you're dividing, essentially the same thing happens. If you've got the square root of one thing divided by another thing, you can split that into two parts. The square root of the first thing divided by the square root of the other thing. So, for example, if you had the square root of 50 over 4, the first thing that you could do with that is split it into the square root of 50 divided by the square root of 4. Now, the 50, you could break that up into 2. 50 is 25 times 2. Haven't done anything with the 4 yet. And then the 25, you can find the square root of that. The square root of 25 is 5. So we'd have 5 times by the square root of 2, splitting that into two separate square roots. And the square root of 4 is just 2. So 5 over 2 times by root 2, or 5 root 2 over 2. That would be the answer. Okay, 3 examples like that for you to have a go at yourselves. Pause the video, try them. Once you've tried them, come back to me. Okay, we'll go through them together. The first one, the square root of 75. Now, the first thing you have to do with that is split it up into 25 times 3. You can't find the square root of 25. You're hoping that you'll be able to factorize it into parts where at least one of those parts you can find the square root of, which you can in this instance. So the square root of 25 is 5. The square root of 3 is the square root of 3. You can't do anything with that. So 5 root 3 would be the answer. Root 27 divided by 3. The root 27. 27 you can split up into 9 times 3. Again, you're factorizing it, hoping that one of the factors will be a perfect square. 9 is a perfect square. We can square root 9. So the top will become 3, the square root of 9, times by the root of 3, all divided by 3. Now you've got 3 on the top, 3 on the bottom. At that point, you can divide the top and bottom by 3, and you do just have root 3 for the answer. The third question, 7 root 5 plus 2 root 45 minus root 80. Don't be put off by the number of terms. Just treat them all separately. Now, 5 is a problem. You can factorize it into 1 times 5, but that's it. So there is nothing that we can do with the first term. However, the second term, 45, that's 9 times 5. And the third term, 80, is 16 times 5. All of which is positive because 9 is a perfect square. 16 is also a perfect square. So the square root of 9 is 3, which is where that comes from. The square root of 5 we can't do, so we just leave it as root 5. The square root of 16 is 4, which is where that comes from. The square root of 5 we can't do anything with, so we just leave it as root 5. Tidying that up, we've got 7 root 5, 2 3s are 6, so we've got plus another 6 root 5, and then take away 4 root 5. That's just like saying 7x plus 6x take away 4x, because all the roots are identical. So 7 plus 6 is 13, 13 take away 4 is 9. We've got 9 root 5 in total. Okay, another example, another 2 examples. Again, pause the video, have a go at doing these yourself, and then restart the video again. Okay, Question first of all, so we've got root 3 times by all of this. Now, 5 times the root 3, that gives me 5 root 3. Root 3 times root 12. It's using the rule that we used before, but backwards. We can join the 3 and the 12 together because we're multiplying. So root 3 times root 12 is the same as the square root of 3 times 12. 3 12s are 36, which is where that comes from. And the same with this. Root 3 times 3 root 2, the 3 outside just stays where it was, but the 2 and the 3 we can multiply together. 2 3s are 6. So we get 5 root 3 minus root 6 plus 3 root 6. Then we see if we can do any more tidying. And we can. The root of 36 is exactly 6. So we've got 5 root 3 minus 6 plus 3 root 6, but that's it. I don't think we can do anything more to simplify that. The second question, 4 minus root 5 times by 3 plus 2 root 5. Both things here have to multiply both things here. First of all, I'll do the 4 times by the 3. That gives me 12. 4 times the 2 root 5. 4 2s are 8, so that's 8 root 5. The root 5 times by the 3 gives me minus 3 root 5. And then the last pair, 2 root 5 times by root 5. 2 times 1 is 2. Root 5 times by root 5 is the root of 25, which is 5. Or you could just say root 5 times root 5 is 5. Tidying that up, we get 12. Take away 10 over here. 12 take away 10 gives me the 2. 8 root 5, take away 3 root 5, gives me 5 root 5. Which brings us to the end of this section. If you have the textbook, turn to page 13 and have a go at exercise 1E. Okay, that is the end of the lesson. Thank you very much for tuning in and cheerio.